Hello, it's Dr. Mike here for my CIS-2808 Introduction to Computer Forensics. This is topic 5. At the time of this recording, it usually is around week 5 for a 16-week class. And this is the Linux file system, and also some looking at Linux artifacts. So topic 5, and it's going through chapter 5 currently of the current textbook. I'm not going to read you the chapter course, but we were going to go over some basics of file systems for Linux, some basic commands, and also how it works with mobile. So anyways, the text is going to go into the file system boot process. Very important to understand that. Boot process is coming off of our previous topic, which is bootloaders and just disks in general. I'm going to focus more on the file system layer. So there's some stuff in the textbook there. With file descriptors and so on. File name layer, also very important to look at, and metadata layer. And we actually have other tools, deleted data and so on, and also how services are started. So the chapter is pretty good about laying out the basics of Linux. I want to give you sort of just a demo of where to look around and what to use for Linux. So first off, let's talk about the disk level. And some of these commands are going to be probably look a little familiar if you've taken Linux classes before. If it's been a while since you've been in Linux, these will hopefully be refreshers for you. So our list command, ls. So definitely can do this. And, I did a tab there, tab completion, definitely a Linux hint there. So ls is our list command. And we can list out all files. ls-l, pretty important here. This -l here is going to give us the long list, which gives us information about the permissions of the files and the ownership of the files and so on. Last access date. So pretty basic command, still good to use. We get the file size here. You can always add on ls-lh and you get a more human readable file size, 29K. ls, just your standard command, is going to be used. Use it just in general, get all the files, look at an individual file. Pretty important thing too is ls-l a. So if I do ls-l, you see all the files. If I do ls-l a, there's no hidden files here, but any hidden files, do ls-l a on my home directory. There we go. So you see there's hidden files here. Viminfo. Let's actually sort this. ls-l tr a. There we go. So we sorted by date time. You can see there's .config, there's a .john, .cache, and so on. .mozilla. That's probably a good one right there. Later on, we will look at browser forensics. You're going to look at this. Definitely Mozilla is one of them. The thing about the A is it's going to expose these hidden files. Hidden files by nature are not hidden for any subversive reasons. Typically, they're just usually caches. These are system files that normally you don't need to deal with as a standard user. But someone could take a directory and move it to hidden, or put stuff in a hidden directory that you might think, well, that's just that's the .gconfig. Probably nothing inside there, but it's always worth understanding that stuff could be put inside here that maybe could be evidence. So anyways, -l-la. So of course, let's go back and look at, we have ls-l. Now, an important thing is, this gives us just some of the real basics about our file with the ls-l. Again, ls-l is great for looking at large groups of files or in directories and so on. An individual file, though, the stat command. So we can stat hex file. Stat's going to give us a lot more details about the individual file or directory. In this case, we get probably most important is the actual dates here. In this case, this is a hex file, regex cheat sheet.pdf. We see the size, information about the number of inodes, and so on. But really important actually is the ownership, the user ID. And we have not just the user name, we actually have the ID number attached to it, which is 1000. The group ID. We do see permissions, which we see up here also. But even more important is probably this, the access, modify, and change times, as well as the birth time. So Those three right there are probably the main ones. When was the actual access, modify, and change time of this file? So you can see they're different, and those can be important to capture as part of your metadata about the file itself. So we haven't actually looked into the file. We'd actually look about the file. So this is metadata information. That's what the chapter refers to. And of course, we have tools that will gather this. I'll probably say this again and again. It's good to also know manually how to go in and do this. But granted, yeah, if you have 300 or 400 files you need to get this from, there are tools that will pull all this information for you. And we're going to look at those later in the course too. Just be aware though, now you know how this be done manually, and also how these tools will usually operate. So that's some file information there. Some other stuff we can look at for disks. Probably the most important one is, now I'm going to run sudo here. I'm using SANS, SIFT workstation, just to demo this. And of course I'm in as a regular user. You should understand what user you are. I don't want to get into the depths of Linux, but understand what your user are, what your access rights are. I just booted in normally, and so I had to use sudo fdisk-l. So sudo fdisk-l. This is a great command. Fdisk itself is normally used for creating partitions, which we don't want to do. Maybe you want to create one on a blank disk for some reason, maybe to store evidence on. But I'm not going to get into that part too. That's more of organizing your storage needs. But fdisk-l is a fantastic way to list out all disks on the system itself. So doing that, you can see using the Linux format or file system hierarchy, normally everything is on the dev directory. I'm going to come back to file system hierarchy here in a minute. Understand though, dev is where devices are stored. In this case, SDA. So just a real quick about this. Again, dev is our standard device directory. Everything in Linux, all devices. Pseudo devices, hardware devices, and pseudo means it's sort of a fake device. For example, there's a dev zero device that creates zeros. There's dev null, which is like the bit bucket. So these are not actual real physical devices you plug in, but also physical devices like disks, network cards, all end up in the dev directory. And again, there's a quick primer here. SDA. SD is a type. I think it's a SCSI attached drive, and A is the first physical one. So we actually have a physical drive called SDA, and in there we can see our partitions, SDA 1, 2, and 5. So again, this is dev SDA a 1, 2, and 5. So these are our partitions. And now we're leading back into previous topic, which is about disk partitions. So you can see how this is going to help you figure out what partitions are there. In this case, dev SDA has a Linux partition, extended, and swap. So let's go and back this up with a df command. So df-h. So df is sort of like our disk use command. It's going to show us both. Again, here's dev SDA1. You can see it maps here. This is our Linux partition. This is part of our system. This is our root part system right here. So it's the root of our system. So we can sort of draw that right there. We see how much it's used and so on. There's a dev SR0, and that's a read-only device. And this is for a image. In this case, a 1.5 gig image. It's a ISO image. And it is of the Ubuntu system. This probably comes packaged with this SANS SIFT. This is like basically the basic OS. And we see there's a dev SDB device also listed here. And we can see how large it is and how much space is being used. And on there, dev SDB, which I actually have plugged in a thumb drive. SDB. So this is our, again, this is our second device. It goes A, B, C, and so on. And we can see it has a number of partitions. 1, 2, 3, and 4. It's got 4 partitions. We can see the sizes. Now we see that there's a one partition being shown up here. It's a single partition, and it's 30% full. It's 3.8 gigabytes. So it's probably the largest one here. And but there's a couple of small partitions here, which was actually a little suspicious. So I'm not going to get into that right now. But anyways, we can see the number of partitions. So this is actually a good demonstration here. Is df will show us just one thing, but under the hood there are actually other partitions. In our case here, there's an extended partition, which I'm not going to go into. That is a way to deal with the 4 partition limit. Remember from our previous topic, standard partitions, master boot record only has room for 4 partitions, so the last one is typically made extended. Swap space, this is basically like our virtual memory, so very important maybe to be able to identify that for an operating system. If it's live, you might want to be able to capture that, and there are tools to do that too. Being more important here, this is a movable drive. There are several partitions here. Some are really small, 27 megabytes, 544, and we have basically a couple, almost 1 gig here. So I know listed out. So again, SDB 1, 2, 3, and 4. So this is going to help us identify our dev directory. Helps us identify with fdisk-l all disks that are associated with the system. df-h is going to show us what's currently mounted and its use. So that's an important thing there is what's currently mounted in the Linux system, and we see its use. So now df is going to show some other things here, tempfs, udev. These are virtual drives. We're going to come back to that in a second here. We're going to come back and talk about proc. Linux has several virtual file systems that look like real file systems. You can navigate to them, you can look at them. Really, they're actually only in memory. They're not on disk. And we're going to talk about one specifically here in a minute when we get into more of the Linux artifacts called proc. But for now, let's go on with disks here. So I think it actually does it actually. So that's some basics there. And then you'll probably see some more in-depth stuff in the labs. But I just want to show you some basics about some basic lower-level disk use. fdisk-l. There's one called tune2fs that will also give you information, which is a -l. But fdisk-l is a great one. Tune2fs, tune2fs-l, and then you give it a device. So let's do dev sd. Let's do sdb. One. There's no 2 blocks there, so let's do SDA. There we go. So Tune2fs is really specific for Linux. So this thumb drive I got mounted is probably not. It's probably like a fat file system table on there. So you get a lot more information here too. You get blocks, block counts, inode counts, and so on. The text talks about inodes, so I won't dwell on that. You can see information. So you get a lot of information about that with Tune2fs. So I think we covered most of that. Yeah, df command. So df-h, we saw that. Talk about inodes again. df-i. Information, just general information about inodes. Again, stat will give you the information too. Tune2fs actually will give you way more information about your inodes. Again, the inode usage, I don't want to dwell into that. The text talks about that itself. Inodes definitely are sort of the building block for your disks for Linux. But -i will just give you inode usage. Something that's probably just you probably want to gather as most information, but honestly, when it comes to disk use, most of the time a disk will be full from file sizes versus inodes. It's hard to really use up all the inodes on real disks. You can see here this is a this Red Hat 4 GB thumb drive I have here. Is not having inodes on it. Is probably a VFAT file system. So, all right. So let's talk about the artifacts. So again, we cover most of the stuff here with the disk information. System artifacts. So after the boot process, we have things that start. I'm not going to get into that here, system V and so on. It's good to be able to read and see what starts and runs, though. And the text will talk about this, just to get an idea about the system itself. The idea being if it's a server, it's going to run a lot of server-based services. And a daemon is just a service. It could be like your email, a print service, secure shell, and so on. This information about the system might lead to what kind of I/O you will have. Is it network-based I/O? Is it like a print server? Is it outputting to a printer? That can be very important for gathering evidence. So, but even more important is here is a file system hierarchy. So it's mentioned here in the text, and I actually have, I believe, in this shell, we have the Linux file system hierarchy PDF listed here too. This is really good to understand basically all those directories, and we talked about this already, like for /dev, that's our device files. But we have temp, var, lib, and so on. What do these directories mean? I'm not going to read these to you, but understand what they are. It's going to help you figure out where to go find evidence. And we're going to browse into a couple of these here, specifically Etsy, and something called Var Log, actually. So, as well as some user home directory stuff. So, and then we have root directory and /home, where most users directories are at. So, just this basic understanding of where stuff is laid out in Linux is very important. And I'll go in, I'll cherry pick a few things and show you, but let me move past this here. And this is outside the textbook. Yeah, user accounts and so on. Here we go. We'll come back to that. There's a great resource. If you Google OWASP mobile security testing, you'll probably find this page here, or at least from the OWASP itself. Now, this is really a cybersecurity. I used this resource before. Used this resource in the past for doing mobile app pen testing for an engagement I did. But really, for forensics, it's going to be very helpful too. So I know this is going to be a mobile pen testing guide. It's a security guide, but there is some stuff here I like to bring out. So first off, Android and iOS are both Linux based, at least BSD, Unix. But what you can do with is you're going to deal on the command line. You're going to have a lot of the similar commands, and you're going to use a lot of the same techniques you would on a Linux system as you would on a mobile system, both Android and iOS. And there's actually an aspect here I want to bring out. There's a GitHub repo. It's a Git book. If you click on this, you'll get the GitHub here. You can ignore this up here. Scroll down to the testing guide. I would suggest downloading the guide also. It's a PDF version. It's a great resource because as you look through here, there's Android testing and iOS testing. Now there's platform overview. There's some good stuff here for platform overview and data storage information. Everything else here is really more for pen testing. So as an example, let's look at our Android data storage on Android. So here we go. Let's talk about how stuff's stored, how things are laid out. There's SQLite databases and so on. Preference files, how they work, and these databases. So these databases could be actually very important. And you notice these are actually .SQLite databases, so there are SQLite viewers you can use. Android SDK has a built-in SQLite database viewer. I have one on all my systems. There's a free one you can get. These can be very valuable evidence. You might be able to pull out this any kind of Android database SQLite and look for usernames and so on. So if it's encrypted, you might have a password attached to it. So again, I'm not going to get into the things here. Then internal storage, how stuff's laid out internally. Our key store. You can realize that there's a lot of sandboxing with apps on mobile, more than you have on a desktop or server. So that's for security reasons, but it's going to make looking for information a little different on mobile versus a Linux desktop or laptop. So again, I'm not going to go through that here. There's information here, a lot of information about the keychain and so on. Same with the iOS. It talks about how it works, the hardware key, passcode keys, the data protection hierarchies there. So good information, background information here, the APIs, but stack analysis, where you go look, when you attach an actual device and you actually maybe attach to it either SSH or you come over over a console command, console session, where stuff is stored, how's it stored, the JSON files, the databases. So this is a great just reference, and again, this is the OWASP mobile testing guide, as well as I would also suggest go to the basics. In this case, this is the documentation archive for the file system basics about iOS. Look at the main developer sites. learn how apps are bundled, learn how data is contained for documents and so on. So again, there are, when it comes to mobile, there are specialized tools that will help you really sort of navigate the little more labyrinth of mobile file systems, at least the metadata layer and the app layer. But you can see here you go. Here's the common used directories, applications, library, network. So you at least you know where to jump in and look. So if I go to users, note here, this uppercase U for users too. It is case sensitive. Desktops, commands, and so on. Sandbox apps. So information out there is a lot of it. Again, there'll be tools to help you with this. Tools to help you deal with mobile. So, but at least you understand where you probably go for further information. Let's go back to Linux, just in general, and some of these artifact areas. So these virtual, talked again about these virtual, there are virtual like udev, tempfs for dev, shm, runlock. These are virtual file systems. There is one in all Linux systems called proc. While the system is running, this is a virtual file system. Everything you see here is in memory. So a lot of these things. Let's look at a file here. We have modules, drivers, console, CPU info, for example. So CPU info. You look at this file, it's 0 byte size. But if I cat the file out, if I cat out CPU info, there's information there. So like how can that be? Well, again, there's nothing here written to disk. But there's a lot of information you can scrape about the system. So I can get metadata information about my OS. And there's a lot of stuff here. So again, let's look at LS here. These numbers are process numbers. And so these process numbers themselves, I could probably see the process information about like open files and so on. So let's look at this cat partitions, for example. So there we go. So we can get information about partitions that are currently mounted, number of blocks, and the major and minor numbers on it. Again, we have divsdb, we have SDA1, 2, and 5. Now, again, we saw this before with fdisk and df, but again, this is an example where you can find information about cat file systems. And we can see all the file systems that are supported for this current operating system. So we ext2, 3, and 4. Those are the main ones. ext4 is one of the main ones. vfat's a common one. encryptedfs, rootfs, sysfs, and so on. So again, a lot of information in proc, and I don't have it up on a tab on this, but if you look at Red Hat or CentOS proc, you Google that. There's entire development guides for everything in proc. So I want to bring up here. I'm not going to move on from this. So just FYI, proc is a file system. Now, one of the file systems listed we saw here is etc. etc. This is good for this host-specific information about your server. So again, it's configuration information. And so etc, one of the ones in FE is Fstab. So Fstab will tell us what devices, what drives and partitions are mounted during boot. In case you come up, it's good to grab this information. If the system's already running, you should have those things already mounted, but still, sometimes someone can manually unmount a drive. And some of these drives listed here can be network mounted. So there could be a network device mounted that is actually supposed to be mounted upon boot, but maybe it's mounted manually. And that'll be listed here at Fstab. Again, I'm not going to go into the details of Fstab, just realize what it is and how you can use it. So with evidence gathering, you might always want to gather a copy of this. And this is a text file, so I can just cat it out. You saw cat etc Fstab. So it's simple as that. I can cat it out, maybe cat it out to a file. Again, we can redirect it to a file. Maybe I do it in home, sans forensics, and maybe I call it, you know, info.text. And then there you go. So now I can build this information of text. I may put that to an external hard disk or something like that. It's a thumb drive or so on. I'm just going to gather information. Again, really and realistic, there's probably tools that do this. They're just going to go through your system and inventory it, gather all the information about all the disks and partitions, and we'll see those in the class. But you can also do it manually. So I'm trying to balance this between not showing you how to do Linux. But you saw the example that you can do some simple commands to gather information. So Fstab, very good. Another one, of course, there's other stuff in Etsy, but probably one of the big ones here. I'm going to do sudo cat Etsy password. So Etsy password, there's the command. The file itself is passwd. I know it's not it's password, but it's not spelled word. Here you can get information about all the users. Probably a real good one to gather, right? So I can gather this. And again, I can send this to home, sans forensics. What would I call that? Something.text. I just forgot what I called it before. Info.text. So again, I can send that there if I want to. Let's do that again here. So these are all the users in the system. Now, not just our carbon-based Lifeform users, but also service users. In this case, SSH has a user. Here's an actual regular user, sans forensics. That's the user for the system. There's the user ID and the group ID and the home directory and their default shell. Now, you notice here we have system users like SSH. It's user number 121. It's part of a different group. It actually has a different home directory and actually doesn't have a login shell. User spin no login is a sort of a way to say there's no active login shell for this user. It needs to have a user for this SSH service. By the way, it's called secure shell. So when it runs, it actually is attached. It doesn't attach to root. It attaches to SSH. That's in case, and it's a security thing. In case someone breaches SSH, they don't actually have a root. They don't have a shell to use, and they don't have root access. So you'll see a lot of stuff listed in this file that is pointed for system services. But it's good though too, because this might also tell us what system services are installed. So do we have in this case, do we have a web user? In this case, we do. Var www, we have a web browser and so on. Is it running a website? Top of the list, of course, no surprise, root, daemon, bin, sys. We have these sort of base level systems. But further down the list, you'll find other users. Now, part of this, sudo, I didn't show you here, but what you don't see here, you see an X right here. So here's sans forensics, the user ID. We have it's colon delimited. There's an X, then the user number, and the group number for that user. There is also an X. So what does the X mean? That's where the password used to be. Etsy password used to hold passwords, and it wasn't raw text, but it was a sort of called a hash of the password. But the way this Linux works is this has to be world readable. So if we look at this file, it has to be world readable, just the way the system works with Linux. And they found that, well, shoot, everyone can see all the passwords, and they can see all the hashes for them. Well, you can collect the hashes, take them offline, and you can crack them. So the way they fix that is they actually made a file called ls-l etsy shadow. And it is where it's another artifact file would grab. You definitely need root access for this file. It's not world readable. It's locked out. Of course, it's read-write for root and read for the root or the shadow group. So in this case, if I sudo cat etsy shadow. There we go. So now we can see all the users. Now we can see a lot of these don't actually have passwords, or they had to have passwords set upon login. But here we can see here's sans forensics, and here's the password hash for it. So There's ways to capture this, and it can be smart. If the user directory somehow is encrypted, if you have root access, you can have access to everything, but it's good to gather this file gather Etsy shadow along with Etsy password as part of your evidence collection. In case you can use other offline tools, and we'll look at this in definitely a later lab to do password cracking. So yeah, you do a little bit of cybersecurity cracking type stuff. Work with forensics sometimes. So now let's talk about non-Etsy files. Let's talk about one of the main ones here, and it is our Var directory. So Var is a place for variable things. So in this case, we might find if we have run an FTP server, that could be Var FTP. If we run a website, we see that there's an HTML directory here, and there's index.html. So if they're running a basic web server, maybe this is a step in the corner of the house, but it's running a basic website, either externally accessed or internally accessed for a maybe there's evidence on there. So again, but one of the big ones here is Var Log. You'll see in both Windows and Linux, log files are really a cornerstone of evidence collection. So go to log, and we can see we're in, cd to var log. So let's type that there. There we go. So var log, a lot of stuff here. A couple main ones. Let's do ls-ltr here. We have logs specifically for services. So say it's Apache. Cups is a print service. Samba is a service that you can use to do network sharing with Windows. That would be a good one. So there's information about what's running there. So you can definitely gather information about those services, which the chapter talks about earlier. It goes into talking about boot services. So again, so what's running, and whatever's running is going to create some sort of output. So that's always also good to look at. But let's come down more to the system level. A couple things here are going to be pretty important. One, of course, is our kernel.log, our syslog, and our auth.log. So I'm going to use something called the tail command, if I type correctly. So auth.log, I can see who's logged in. In this case, date and times when users have logged in. That's some great information right there. What commands they ran. In this case, look, remember I ran this a little bit ago, 1109. I did sudo. I sudo catted Etsy shadow. So now as evidence of who logged in when, we actually have evidence of who ran what. So very important there. So auth.log is a good one. And the last one here we look at is tail our kernel.log. So information you can see when disks were removed or attached. In this case, there's an SDB 5 ago. Actually, information about what was attached. So this is really good. You can go back in history and see when someone has either, in this case, a USB device, which I did. I plugged in a general disk here, and it's 4 gigabytes in size. So get information about what was plugged in and unplugged from the system. So again, this is our kernel.log. All right, so on the CD here, I'm going to go back to my home directory. So let's talk about our home directory. Home directory is where we have all of our users, other than root. There is a root directory called /root. Again, I can't see it. I have to sudo it. Nothing inside looks like. This is for our root user. Always look there too, but also in our home directory we'll have a list. If I had a user, Dr. Mike, a user Bob, whatever, there could be different users listed here, each with their own user ID and their own files. So I'll CD again, take you back to my home directory. A couple things here, probably a big one again, those hidden files. So if the user has Mozilla, for example, right away, that's definitely going to be a good one. If they're running anything local, we'll see later on when we look at more evidence artifacts like browsers and email. There's going to be stuff in user home directories. as of course as well as their files that they access. Big one here though I want to show you is our bash history. So it's a hidden file, and it gives you everything I've typed. Looks like I did some Docker stuff here, or someone did. Everything that was done. Like someone had a case file out, unzipped. So all the things that are running, you can see here I actually did some stuff for this class. I was MD5 to the zip file and so on. So you can collect information about what a user has typed. This is also like doing history itself. And how I do history, I get my history. But as a root user, if I can go to each user directory. If I become root, or if I do the sudo command, I can go into each user directory and I can collect information about what they ran. Now, of course, you think, well, if they're smart, they will clear that file out. Or if they try deleting it, that's probably bad because it could be recovered. What it could do is go in and actually open the file as an editor and clear it out. So keep that in mind, but still, it is an evidence item. It's going to be under the home directory. So for the user's home, so /home. So again, a lot of information here. This is a great resource. The Linux file system hierarchy. It's going to give you all the information about what's inside here. And then this really gets into the details. The boot directory is also good. Device directories and so on. So I'm not going to go read that to you. That is linked in the course shell. And we talk about user accounts, so Etsy password and so on. This is part of the text. So what I didn't cover was Etsy groups. Also go and look at. Look at Etsy group. Talk about Etsy shadow and home directories. Again, documents, downloads. If the user is using it almost like a regular system, they're not encrypting everything. Let's say the user documents, I guess. Documents, downloads, desktop, pictures. Definitely look at that. There's stuff here about SSH and shell history, and we talked about logs already. So there's a good list here about different logs, mail logs, news, syslog, user logs, and so on. Tip here, this is where you get into operating system level stuff. The OSs might have different types of logs. And then I already closed them. This is where the Android and iOS, or any file system, if you're dealing with different flavors of Linux, you might find different log files being generated. So always look to that about logging. But there's some common log files here that are listed out. If someone's printed something, that's also a good one. So the cups log could be a great one. So anyways, I think that covers it for information about Linux disks, and even more specific about some of the commands to browse around Linux, and also some of the metadata layers for files, and then actually metadata and data about Linux itself. So, hope this is helpful, and thank you for watching.